Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve question number 14, NEET Physics paper 2017. Hello students, let us solve question number 14. It says Young's double slit experiment, that is YDSE experiment, is the first performed in air and then in a medium other than air. So this experiment is conducted in two medium, one in air and another in another medium. It is found that the 8th bright fringe in the medium lies where 5th dark fringe lies in air. What is the meaning of that? That we have a medium and air medium. This is any medium other than air. So when the experiment was conducted here, 8th bright fringe in the medium. So 8th bright fringe, that is X8 medium, lies where it coincides with the 5th dark, that is X5 dash of the medium, that is air. The refractive index of the medium is nearly. Now we know that in double slit experiment, for this medium having wavelength, suppose lambda dash, for this the wavelength will be lambda, and these two are related with mu, because lambda dash is lambda over mu. So I can write this lambda dash as lambda over mu when required, because then only you can find the refractive index of the medium. So our aim is to find this refractive index of this medium. 8th bright can be written as 8 lambda d by d, that is lambda dash d by d, and here it is 4.5, because this is 5, so it is 4.5 lambda d over d. First let me solve, then I will explain to you why this is the situation. Because okay, let me just tell you why it is done. In a double slit experiment, this is source S1 and this is source S2, and the source is here, main source. This is the two coherent sources obtained. This is the central right fringe. When it is any medium, the position where we get the 8th bright fringe, suppose this distance is x8. Now the ray coming from here and the ray coming from here, the meet, interfere and produce the 8th bright fringe. So there are many other fringes over here. This distance is x8. Now when this medium is removed and it is air, now this same position is occupied by the 5th dark, when the wavelength here is lambda and here the wavelength is lambda dash. So therefore we equate these two lengths, because at the same point from the center we are getting the different bands. Now we know that general expression for any nth position of bright fringe, it is n lambda d by d, where lambda is the wavelength used, n is the order, and d are the distance. Capital D is the distance of the screen and the slits. Small d is the distance of separation between two slits. So this formula is known, and that I can directly write n beta. Beta is the bandwidth or fringe width. For dark fringes, I use this one, nth dark fringes. This is n minus half lambda d over d, which is n minus half times beta. This is the formula we are going to use. So because in the question it is given that the eighth bright fringe, so therefore n is 8 lambda d by d, 8 lambda d by d, but the wavelength here is lambda dash used here, so that is lambda dash. Why it is like this? Because this is for bright dark it is given 5, so 5 minus half beta, that is 4.5 beta. Beta is this, so 4.5 lambda d by d. So therefore I have used this one. Now our aim is to solve this, so let us solve. 8 lambda dash is lambda by mu, and d by d equals to 4.5, that is 9 over 2, I can write 9 over 2 lambda d over d. So from here I have to solve to get the value of mu. Lambda d over d and lambda d over d will cancel out, and mu will be 16, this will go there, is 16 over 9, which is equal to 9 1 the 9, and then 7. Now it is left with 7. 7 put 0, so it is 70. So 70 means 9 7 ja 63. So it is 63. So it is 7 left. Again it is 1.7 something. I don't know to need to calculate that, because already we got 1.7, so the answer will be 1.78. If you go for that, you will get the answer 16 divided by 9, it will be 1.78. okay, so this is the refractive index of the medium. So the answer to this question is option number 4. Thank you.